Hi grade 10s, it's Miss Thangraj here, and today we're going to do a video where we're going to find the x-intercepts of a quadratic. Recently in our videos we've been looking for the y-intercepts, and today we're going to look at the x-intercepts. So what I want you to do is please go get a piece of paper and a pencil and a calculator so you can do some math with me while you're watching the video. That's going to really help you to understand this video a lot better than just sitting back and watching. This video is really going to focus heavily on Desmos. We're going to rely on Desmos to help us find the x-intercepts. So don't feel bad if initially you can't find the x-intercepts without relying on Desmos. Desmos is a great tool and we're going to use it a lot today in this video. So the question that we are going to ask throughout this video is, can you determine the x-intercepts by only looking at the equation? That is our goal by the end of this video. By the end of this video, we want to move away from relying on Desmos and be able to find the answer for the x-intercepts just by looking at the equation. If you look at lesson number 5 from assignment number 4, you can see this beautiful chart, and in the chart it gives you a whole bunch of different equations for quadratic graphs, and we want to find the first x-intercept and the second x-intercept, and to do that we are going to use Desmos. So we're going to start by looking at the equation in factored form first. So let's look at this equation in factor form. Y is equal to x minus 3, x plus 5. Notice the x-intercepts. Positive 3 and negative 5. In the bracket it says minus 3 and the x-intercept is plus 3. In the bracket it says plus 5 and the x-intercept is minus 5. Let's look at the second equation. Y is equal to x minus 1, x minus 2. In the bracket we have minus 1 and minus 2, and in the graph we see that the x-intercepts are plus 1 and plus 2. I think we're all seeing a pattern. Okay, let's look at a third graph. Y is equal to x plus 2, x minus 4. So it says plus 2 and the x-intercept is minus 2. It says minus 4 and my x-intercept is plus 4. Opposite still. Good pattern. Okay, a fourth. If I have y is equal to x plus 6, x plus 2, in the equation, it's two positives, plus 6 and plus 2. And on the graph, it's two negatives, negative 6 and negative 2. Okay, let's look at one last equation in factored form. Y is equal to x plus 3, x plus 4. Again, two positives in the equation, plus 3 and plus 4. And in the graph, the x-intercepts are minus 3 and minus 4. I think that most of us are okay with factored form. That's easy. The problem is that when we get an equation in standard form, when we look at that equation or look at this equation, we don't know where or how to find those x-intercepts. So right now, let's not worry about standard form and let's just focus on factored form for the time being. So what I want you to do is I want you to go back to lesson number 5, and I want you to find or enter the answers for the last 3 equations in that table. For the last 3 equations, and all 3 of those equations are in factored form, so I think you can find the answers for the x-intercepts for those. Press pause. I want you to do that math. I want you to try to find the x-intercepts on your own or using Desmos, and then you can come back and you can check to make sure that you got your answers correct. So I really hope you tried this on your own before checking your answers. You can see that I have filled in the table of values with the right answers. The first equation was x minus 1, x minus 2. So the x-intercepts were plus 1, 0, and plus 2, 0. The second factored form equation was x plus 4, x plus 3. So my intercepts were minus 4, 0, and minus 3, 0. And then the last equation in factor form was x minus 3, x plus 5. So that means my intercepts are plus 3, 0, and minus 5, 0. So when our equations are in factored form, it is easy to find the intercepts. You just take those numbers that are in the brackets and you switch the sign. Now, the hard part is trying to figure out how to do that when your equation is in standard form. And we're going to start looking at that today in this video, but really that's going to be what the rest of the videos this week is going to do. We're going to try by Friday to figure out how we can find those x-intercepts for an equation in standard form without having to depend on Desmos. Here we have an equation in standard form, so it's not going to be as easy to find the x-intercepts as it was in factored form. So our equation is y is equal to x squared plus 2x minus 8. And there is a pattern that we can see. We can notice that if I multiply those two x-intercepts, the 2 times the minus 4, it definitely gives me minus 8. So that's interesting. I've got another equation that's in standard form, y is equal to x squared minus 4x minus 12. And again, the same pattern happens. When I multiply 6 times minus 2, it gives me minus 12. So that's an interesting pattern that seems to work when we have standard forms and x-intercepts. What we're going to do now is we're going to go back to our chart method that we learned at the beginning of this unit on quadratics. And we're going to see how we can use that chart method to help us figure out what the x-intercepts would be of an equation that's in standard form. So we have this equation in standard form. That's what we started with. And when we graphed it, we saw that we got this graph. And it was interesting because the 2 times the negative 4 gave us negative 8. Now, what I want to do is I want to go backwards in the chart. And today is just the first time we're doing this. It's going to get easier, so don't feel overwhelmed. Okay, so normally we start off with something in factor form like this. I put x plus here, and I find the middle, and I know that I would get something in standard form. And I know that this minus 8 over here should be right there. That's what we've always found so far. So let's look at our graph and let's go backwards. I know that if my x-intercept is minus 4, I know that in the equation it should be plus 4 because this number in the equation and this number on the graph should be opposite. Here, if I know it's plus 2, then I know that in the equation it should be minus 2. So I'm going to use a chart method now. So x plus 4, x minus 2, x times x is x squared. Just like we wanted, the 4 times minus 2 is minus 8. That's awesome. Now somehow what I want is when I simplify, when I put these two things together, I want to get a 2x. So let's make sure that works with the numbers I have here. Here I have 4x. Here I have minus 2x. If I put 4x and minus 2x together, it gives me plus 2x. So it's worked exactly like I wanted to. Now, the reason we are able to figure out these numbers here is because we had a graph. So today we're depending on the graph, but our goal in the end is trying to figure out what these two magic numbers will be in factored form without using the graph. So let's try the next equation together. Here is my next equation that was in standard form and the graph that goes with us. I see that the 6 and the minus 2 multiply together to give you minus 12. What I want to figure out is how those numbers relate to the minus 4 in the middle of the equation. So let's do that right now. This time the equation in standard form is y is equal to x squared minus 4x minus 12. And we are depending on Desmos to help us. And when we use Desmos, we saw that the graph was x minus 2. The graph was, the first x-intercept was minus 2. The second x-intercept was plus 6. So if I wanted to put that into factored form, I know that since it says a minus 2 here, it needs to be a plus 2 in the equation. And since it says a plus 6 here, it needs to be a minus 6 in the equation. And we know that when we have an equation in standard form, the number at the end is always going to go right here. We also know that the x squared part is going to go here. And we know that these two parts together need to give you the minus 4. So let's use our equation, x plus 2, x minus 6, x times x is x squared, 2 times negative 6 is negative 12. And now let's make sure that when I combine these two, it gives me the minus 4 like I want. So I have 2x, I have minus 6x, 2x minus 6x gives me minus 4x. So that means if this is my equation in standard form, then the equation in factored form is x plus 2, x minus 6. And that means that if the equation is x plus 2, I have one x-intercept at minus 2. And if the equation is x minus 6, the other x-intercept is at plus 6. This is confusing, I get it. And today we couldn't have done it without using Desmos to find the x-intercepts. But as we work through our videos, Tuesday, Wednesday, Thursday, and Friday, we'll be able to start here and go backwards to find the equation without relying on Desmos. That is our goal. The last question on assignment number 5 or assignment number 4, lesson 5 says, which form of the quadratic equation was easiest to determine the x-intercepts? It was obviously factored form, and the connection between the equation in factored form and the x-intercepts is just that whatever's in the equation in factored form, it's the opposite for the x-intercepts. You have a little bit of homework tonight. First bit of homework is please don't feel overwhelmed if you don't completely get it when it comes to standard form. That's totally fine. We're just beginning. Your homework is to make sure you understand how to find the intercepts when you have factored form, and then to complete the table for standard form, and please feel free to use Desmos to help you. If you have questions, if you're confused, please come see me on Google Meet this afternoon. I'll be there between 1:30 and 3, and I'd love to answer your questions. Thank you so much for sticking with math and continue to watch these videos while we're learning at home. Please, if you've watched this video, leave me a comment to let me know you've watched. And again, don't feel overwhelmed if you are behind. Any math you are doing at home is helping you. So my goal is not to cause stress. My goal is to just do whatever I can to get you as prepared as possible for grade 11. Don't be hard on yourself because learning at home is hard.